Let us begin this course on electronic product design. This is a very vast topic. It is interdisciplinary. It will have flavor of electronics, trying to control electronic products and even mechatronic products or electromechanical systems. We will at first look at what constitutes an electronic system and try to understand the various blocks and the interdependence, and then see how we can go about designing circuits for each of the blocks so that we can compose a complete electronic product or an electronic system out of the circuits that we develop. The syllabus is also kind of wide-ranging, and you will understand why this specific syllabus once we understand the various blocks that go on to compose an electronic system. This is going to be a design-oriented course. We will try to focus on circuit design and try to make it as realizable as possible. There is no lab component in the course. It's going to be lecture based, but I would encourage each one of you to try out the experiments individually at your homes. Let me now begin with the concept of an electronic system. So let me have this flower-shaped diagram here to represent the plant that that one is interested in controlling. So this plant has few ports. One of the important ports is to handle power or energy. So generally these plants will handle some power and some power flow, and then we may want to control the flow of power through that particular plant. It could be a power supply, or it could be a DC-DC converter, or it could be a motor where there is power flow and you would want to control the flow of power, or it could be an automobile. Again, there is power flow and you would like to control the speed and the torque of the automobile. So there are several systems which are mechanical in nature, electromechanical in nature, or purely electronic in nature, which you would like to control. So these ports, these bidirectional ports that I have indicated here, are power ports, the energy ports. There could also be signal ports, in the sense that you may want to control the flow of information or flow of signals, right? It could be like, as in the case of a radio, as in the case of the television video signal or an audio signal, right? Where you may want to control the flow of information. Okay, so the plant can be anything from a very small system to very large complex systems, and they have two very important ports for controlling called the input and the output ports. So these single line arrows, I am calling it as the information or the signal ports. So let me mark two other ports in red here, called the control input port, and this is the sensor or the sensed signal output port. So now these two ports are important ports, and all our electronics is basically to see that I take signals and informations from this sensor ports, process it in some fashion, and try to try to actuate or give signals at this input port in such a manner that I control the flow of either the energy or the flow of information in the plant of interest. So if you look at this part, and this is the part that most of the electronics come in for all the systems, they can be split into two parts. So one is the analog part and the other is the digital part. So you have the analog world and the digital world, and you need to interface both these worlds. Okay, that is an important part. So if I draw the block diagram, so you sense temperature, you can sense the speed, you can sense the force, you can sense the torque. So there are several parameters in a plant that you may want to sense and pass on the information into the digital world to take control action. So the sensors do the job. The sensors are transducers which convert these parameters into useful electrical signals, and these electrical signals are passed to a block which we will call it as ASP. ASP is nothing but analog signal processing. So this is an important part of the block. And then from the analog signal processing, you pass on the signal to another block called the A to D, analog to digital conversion, and bring the information or the signals into the digital world. Now this is where all your DSP, microcontrollers, computers, all those exist. And here there will be a process called the digital signal processing that needs to be done, like digital filters and so on and so forth. And there will be a reference, and the output of the digital signal processor will be compared with the reference. It will pass on to a controller, and the output of the controller will go through another digital signal processor, followed by not necessarily mandatorily a digital to analog conversion, which will go and send the signal to the control input port in such a manner that it will control the flow of energy or power or information signals in the plant of interest. I will call this as the plant. You can write that down. So that is called the plant, and this entire system here is called the electronic system of interest. So this is the electronic system that you will need to design. So generally, as far as this part of the course is concerned, this blue part is a given. It's a given in the sense that the open loop plant of the system is given to you. It is there. And we need to build up all the electronics which are indicated in red here. The analog signal processing, which may include translation of the signal, it may include clamping of the signal, it may include linear or non-linear processing, may include amplification, translation, may include filtering, anti-alias filtering, so on and so forth. And then pass it through an analog to digital converter, take it into the digital domain. Again, in the digital domain, the digital signal processing part may include lot of filters again. IIR filters and FIR filters, finite impulse response filters and infinite impulse response filters. Then of course the controllers, which could be a proportional or an integral or a proportional integral derivative controller, so on and so forth. And then further digital signal processing and give an appropriate signal to the control input such that the plant here behaves in a manner that you want it to behave. So this is the generic system that we will be working on and depending upon the individual functionalities and individual applications, we will design all these parts which form the electronic system part of any given plant. All these electronic circuits which I have shown in red will work only if they are powered by an energy source, a power supply. So it is important that we have a power source, a power supply, which will supply power to all the electronics in this highlighted part. Let me introduce another block called the power supply block, which I am showing in green. This is the power supply block. It draws energy from the 230 volts mains grid. This is coming from the wall socket. Every home, every place, every lab in the country will have this 230 volts wall socket. So from this 230 volts AC, it needs to be converted to DC, and an appropriate voltage is applied to all these electronics. This voltage may be 5 volts, depends upon the electronics, whether it is digital or analog. If it is digital, you may want to use 5 volts or 3.3 volts power supply, DC power supply. Or if it is analog electronics, you may want to use plus minus 15 volts or plus minus 12 volts DC. So the output has to be appropriately given depending upon the electronics that you want to drive here. So it is very important that you first have this power supply as an important tool in your electronics toolkit. So you need to know how to make this power supply in order to power all other electronics in your electronics systems product. So let us focus on that design of the power supply now.